With the implementation of the remove last complete, we now have arrived at the mighty A list. Now the A list works beautifully, it'll be fast, wonderful, but it has one major limitation, which you can see here, namely that the list can never hold more than 100 items. So in other words, once the concrete reality has reached this point where size is 100 and thus we consider all items in the array used, we know of course that the invariant says that 100 is the place where the next item is going to get inserted. So what happens if we insert into the A list above? Well, we'll get an index out of bounds exception and it'll say, sorry, can't put something in a position that doesn't exist. The next thing you might ponder is, what should we do about it? So maybe think about that a moment. So the most obvious thing you might want is to make the array bigger. Now of course in Java that's not actually possible. So what should we do instead? Well, one approach is what we'll call resizing arrays. Now, of course, this name seems to directly contradict what I just said, which is that arrays in Java can't be resized. So we're going to do something that seems like a little bit of a hack. Okay? So basically what we're going to do is when the array gets too full, in other words, when size equals items.length, when the abstract reality of the situation is that the user expects as many items in the list as there are in the concrete list, then we will do the following. We will say int a equals new int size plus 1. So we'll make an array in this case that is 1 larger, because this has enough room to hold not just the information we already had, but also one additional item. Geez, spam call, go away. All right, next thing we'll do is we'll say system.arrayCopy, yada yada. I'm not going to show all the syntax. So all of this information gets copied from our array to this copy of the array. Okay? And a is just some variable that points to this array. Currently, it has nothing at all to do with our A list. It's just a local variable. Then we say a size equals 11. And by that, I mean, let's go to that last position and put the number that we want to insert. Then, and this is the really interesting part, we take the items memory box and we say, you know, that old concrete list we had laying around here, this concrete array, we're done with it. It's no longer useful to us. It's too small for our purposes. And instead, we're going to make the items memory box here point at this new array we just created. And that will be destroyed by the garbage collector. And now we have an array that is large enough to hold all of our items. So we call this process here in this little range where we create a new array and copy it resizing. Now, of course, we didn't actually resize anything at all. We created a copy and set our items pointer to our new array, but the effect is the same. So we're going to implement this in a moment. I encourage you, before I give it away in the next video, you can try it out on your own. So if you click here on this link, or you go to the lecture code repo, you'll get what we had before, the naive implementation. And so maybe try out doing this, though you don't have to, because you'll have to do this in project 1A anyway, but your choice.